Welcome to Exploration of Basic Mathematics. Trigonometry. Part 3. Sine, cosine, and curves.
The triangle. A triangle is a closed-shaped figure in a plane with 3 angles, 3 sides, and 3 vertices. Three vertices are A, B, C. Sides are AB, AC and BC. Angles are angle A or angle CAB. Angles are angle B or angle ABC. Angles are angle C or angle ACB.
Right-angled triangle. Right-angled triangle has one angle right angle that is 90 degrees. Angle A and angle B are complementary, as angle A plus angle B equals 90 degrees, or angles A equals 90, angle B. To draw a specific right-angled triangle, one must know at least one side of the triangle, along with angle A. Of 3 sides of a right-angled triangle, the opposite side to right angle is always the longest side, and it is called hypotenuse. Other 2 sides are opposite and adjacent to O angle AE. Triangle with 3 sides known. Can we calculate values of angles? The right-angled triangle with 1 side and 1 angle A. Can we calculate other sides? Trigonometrical ratios has the answer. Trigonometrical ratios. We define here the trigonometrical ratios: sine, cosine and tangent. In short, we write them as sine, cos, and tan. The sine A equals opposite divided by hypotenuse. The cosine A equals adjacent divided by hypotenuse. And the tangent A equals opposite divided by adjacent. With the help of sine, cosine and tangent, any side of the right-angled triangle, adjacent, opposite and hypotenuse can be calculated using following form. Opposite equals hypotenuse into sine. Adjacent equals hypotenuse x into cos. Opposite equals adjacent into tan.
Let's explore sine AE.
Please draw 3 right-angled triangle of hypotenuse of same length. And note, as angle increase as A to L and to P, so is the value of sine of angles. The value of sine of angle AE depends on the value of the angle AE. When angle A is nearing 90 degrees, the opposite side is nearly equals to the hypotenuse. And when the angle AE equals 90 degrees, the hypotenuse equals the opposite, and sine AE equals 1. Please note, the maximum value of the sine AE equals 1. Note, as angle A decreases, so is the opposite side. When angle A is nearing 0, the opposite side is very small. When angle A equals 0, the opposite will be 0, and sine of angle AE is 0. Note, as sine and cosine are the ratio of two sides, there is no unit attached to them. Let's explore sine AE. At a value of angle A equals 30 degrees, draw a right-angled triangle. ABC of angle A equals 30 degrees. The angle B equals 60 degrees. Angle C is right angle equals 90 degrees. And the sides of the triangle ABC are A, B, C. Draw an arc at the point B of radius equals to AE to locate a point D at the hypotenuse. So the line segment DB equals BC equals A. The triangle BCD is an isosceles triangle. As side DB equals CB and angle DBC equals 60 degrees, angle BCD equals angle CDB equals 60 degrees, or triangle BCD is an equilateral triangle, and sides DC equals BD equals CB equals to AE. Now focus on triangle AECD. Angle DAEC equals 30 degrees and angle AECD equals 30 degrees as angle DCB equals 60 degrees. It makes triangle AECD an isosceles triangle and line segment DAE equals CD equals AE. So the hypotenuse AEB equals AED plus DB equals 2AE. Using Pythagoras' theorem, AEB square equals AEC square plus BC square. Or 2. AE square equals B square plus AE square. Or B square equals 3. AE square. Or B equals under root 3 into AE. Note here, sine of 30 degrees equals 1 by 2, and sine of 60 degrees equals under root 3 by 2. Also note, cos of 30 degrees equals under root 3 by 2, and cos of 60 degrees equals 1 by 2. Sine of 30 degrees equals 1 by 2 equals cos of 60 degrees. Sine of 60 degrees equals under root 3 by 2 equals cos of 30 degrees. It shows that sine AE equals cos B equals cos 90 minus AE. Cos AE equals sine B equals sine 90 minus A. Let's explore now. Sine of angle 45 degrees. Draw a right-angled triangle ABC of angle AE equals angle B equals 45 degrees. And angle C equals 90 degrees and with sides A, B, C. Note here, as angle A equals angle B equals 45 degrees. Triangle AEBC is an isosceles triangle. So the sides AEC equals BC equals AE. Using Pythagoras theorem, AE square plus B square equals C square. Or AEB square equals AE square plus AE square. Or AE equals under root 2. Note here sine of 45 degrees equals 1 by under root 2. And cos of 45 degrees equals 1 by under root 2. The trigonometrical ratios of complementary angles. The complementary angles are angles whose sum is 90. In a right-angled triangle ABC, angles A and B are complementary angles. And just we saw, sine of A equals cosine of B. Here prefix co in cosine is for complementary. It means that the ratio of the angle is equal to the co-ratio of the complementary angle. Also we define cotangent or cot as cotangent A equals adjacent divided by opposite. Tangent A equals cotangent B. Tan A equals A by B equals cot B.
Trigonometrical ratios. There are 6 possible ratios and all are defined as opposite divided by hypotenuse equals sine A, adjacent divided by hypotenuse equals cos A, opposite divided by adjacent equals tan A, adjacent divided by opposite equals cot A. Other twos are defined as secant or second, cosecant or cosec, hypotenuse divided by adjacent equals sec A, hypotenuse divided by opposite equals cosec A.
These ratios are related as sine A equals 1 by cosec A, cos A equals 1 by sec A, tan A equals 1 by cot A. Also note here, for 30 degrees, variation of sine A and its curve. Please note, the value of sine A depends on the value of angle A, but it is not directly proportional to the value of angle A. To see the clear variation of the value of sine A with the value of angle A, we note more angles between 0 to 90 degrees, and its sine A. Sine A curve. To understand the variation of the value of sine A with A, we plot it on linear scale for all angles from 0 to 90. This is the curve for the variation of the value of sine A with the value of angle A from 0 to 90 degrees. As cosine is sine of complementary angle, the curve is drawn for the variation of the value of cos A with the value of angle A from 0 to 90 degrees. Now explore the sine A. When A is obtuse angle, or angle A is more than 90 degrees. So far we saw the value of sine A for acute angle A. That is when angle is less than 90 degrees within a right-angled triangle. How to find the values of sine A for obtuse angle A? Sine A or any trigonometric ratio of obtuse angles cannot be defined by means of a right-angled triangle, as we know the value of angle A cannot exceed 90 in a right-angled triangle. We will explore the value of sine A for obtuse angle. Take a general angle as theta from 0 to 360 degrees. We know sine value for angle theta equals 0 to 90 degrees. We start with a value of theta more than 90 degree. So draw an angle theta equals 120 degrees. Compare triangle ABC and triangle ADE. Sides DE equals BC equals 0.87. And sides AD equals AB equals 1.0. Sine 120 equals DE by AD equals 0.87 equals sine 60 or equals sine 180 minus 60. Try to understand it this way. When theta is more than 90, we may write theta as 180 minus x, where x is an acute angle. So the sine theta equals sine 180 minus x equals sine x. Sine 120 may be written as sine 180 minus 60 equals sine 60. Or sine 180 minus x equals sine x. Draw an angle theta equals 150 degrees. Compare triangle ABC and triangle ADE. Sides DE equals BC equals 0.5 and AD equals AB equals 1.0. Sine 150 degrees equals DE by AD equals 0.5 equals sine 30 degrees. Sine 150 equals sine 180 minus 60 equals sine 30. Also in same way, Sine 135 equals sine 180 minus 45 equals sine 45 is equal to 1 by square root 2. Now explore sine theta when theta more than 180. Draw an angle theta equals 210 degrees. Compare ABC and ADE. Sides DE equals BC equals 0.5 and AD equals AB equals 1. Please note, the perpendiculars DE and BC are in opposite direction, so we consider DE equals minus BC equals minus 0.5. Sine 210 degrees equals DE by AD equals minus 0.5 equals minus sine 30 degrees. Sine 210 equals sine 180 plus 30 equals minus sine 30. When theta more than 180, we may write theta as equals 180 plus x, where x is an acute angle. Sine theta equals sine 180 plus x equals minus sine x. Or sine 180 plus x equals minus sine x. Now explore sine theta when theta is more than 270 and is less than 360 or 2 pi. Draw an angle theta of 300 degrees and angle of 60 degrees. Compare triangle ADC and triangle ABC. Sides DC equals BC equals 0.87 and AD equals AB equals 1. Please note, the perpendiculars DC and BC are in opposite direction, so we consider DC equals minus BC equals minus 0.87. Sine 300 degrees equals DC by AD equals minus 0.87 equals minus sine 60. Sine 300 equals sine 360 to 60 equals minus sine 60. When theta more than 270, we may write theta equals 360 minus x, where x is an acute angle. Sine theta equals sine 360 minus x equals minus sine x. Sine theta 0 to 360. It is important to note, the value of sine is positive from 0 to 90 degrees. The value of sine is positive from 90 to 180 degrees. The value of sine is negative from 180 to 270 degrees. The value of sine is negative from 270 to 360 degrees. The value of sine is negative for negative angles, too. Variation of sine A and its curve. We know sine value for angle theta equals 0, 30, 45, 60 and 90. For angle theta is more than 90. Use sine theta equals sine 180 minus theta. For angle theta is more than 180. Use sine theta equals minus sin theta minus 180. For angle theta is more than 270, sine theta equals sine 360 minus theta equals sine minus theta equals minus sine theta. Now we extend sine curve on linear scale for angles 90 to 180. Full sine curve on linear scale for angles 0 to 360. Cos A. When A is obtuse angle. In same fashion as we did calculate sine for obtuse angle, we will work out for cos A. Please follow the step and understand yourself. Cos theta, 0 to 360. It is important to note, the value of cosine is positive from 0 to 90. The value of cosine is negative from 90 to 180. The value of cosine is negative from 180 to 270. The value of cosine is positive from 270 to 360. The value of cosine is positive for negative angles, too. Variation of cosine and its curve. Compare sine A and cosine A curves. Now we draw a right-angled triangle and put all trigonometric functions in one place. Draw an angle theta with angle arm equal to unit length. Drop the perpendiculars on horizontal line and vertical line. You will find sine and cosine of theta. Now draw a perpendicular on other end of angle arm and extend it till it meet both horizontal line and horizontal line. In red right angled triangle you will find tangent theta and secant theta and In green right-angled triangle, you will find cotangent theta and cosecant theta. Thank you for watching. You may continue to watch our old videos.